Bismillahirrahmanirrahim. This is question number 6 of exercise 2.3, in which we are given a matrix A and we have to find its inverse, as well as we have to prove that A multiplied with A inverse is equal to the inverse of A multiplied with A, and both of these are equal to an identity matrix. So first of all, we are going to revise our basic information, which is multiplicative inverse only exists for non-singular matrices. And how do we know that if a matrix is non-singular or not? For that, we check its determinant. If its determinant is not equals to 0, then it is a non-singular matrix. And now we also have to devise the formula for multiplicative inverse, which is A inverse equals adjoint of A whole divided by determinant of A. So first of all, we are going to find the determinant and check if it's singular or not. If it is non-singular, then we are going to find its adjoint, and then we are going to put both of these things in this formula to find its inverse. So here this matrix is 2, 0, 2, 1, 1, 1, minus 3, 0, and 6. Now we are going to find its determinant is equals to Now how are we going to find its determinant? We are going to find it using its first row. We can use any row or any column, but the first row is the easiest one. Okay, the first term is to be written as it is, 2. Then we are going to write its minor matrix, which is leaving this on the column that contains that 2 and the row that contains this 2. Okay, so we are left with 1, 1, 0, and 6. Then we are going to write this 1 over here. This is the middle one, so we are going to write a minus sign with it, and then we are going to write its minor matrix, which is, we are going to circle it first. Okay, we are going to remove this row and this column, and we are left with 0, 2, 0, 6. So we are going to write these 4 terms over here in this way, and then we are going to write this minus 3 over here as it is, and then its minor matrix over here. So it will be removing this row and this column, so we are left with 0, 1, 2, 1. So we are going to write it. Now it is equals to 2 into, we are going to multiply the diagonals and the non-diagonals together, and then we are going to substitute negative sign in between them. So 6 into 1 is 6, minus 0 into 1 is 0, minus 1 as it is, 0 into 6 is 0, minus 2 into 0 is 0, then again minus 3 into 0 into 1 is 0, minus 2 into 1 is 2. It is equal to 2 into 6, which gives us 12, then minus 1 into 0 gives us 0, and then minus 3 into minus 2 gives us plus 6, which is equals to 18. And as this is not equals to 0, so A is non-singular. Now we are going to find its adjoint. To find adjoint, we have to make this huge matrix with this transpose sign and then these minor matrices, and then we have to draw the signs of all these minors as negative, positive. We don't write positive, so it's left as it is, then negative, then positive, then negative. This one is positive, this one is negative, and then this one is negative. One positive and one negative, and this way, and in this way we move up till the end. And now we have to find the minor matrices. So for the first element, we are going to circle the first element, remove its row and its column, and we are left with 1, 1, 0, 6, and we are going to write these numbers in the same order over here. And in the same way, we are going to fill the rest of the matrix as well. This is our resulting adjoint. Now we have to simplify it, finding the determinant of all these minors, and then we have to solve it further to find the adjoint. So adjoint of A is equals to, never forget to write this small t for transpose over here. Okay, now we are going to solve it. 6 into 1 is 6, minus 0 into 1 is 0. Then we have this negative sign over here, and 0 into 6 is 0, minus 2 into 0 is 0. Here we have 0 into 1 is 0, minus 2 into 1 is 2. then 6 into 1 is 6 within this negative sign, and minus 3 into 1 is minus 3, so it will become plus 3. Then 2 into 6 we get 12, minus 3 into 2 is minus 6, so it will become plus 6. Then we have this negative sign over here. 2 into 1 is 2, minus 2 into 1 is 2. Then 1 into 0 is 0, minus 3 into 1 is 3, minus 3, so we are going to write plus 3 over here. Then this negative sign, and 2 into 0 is 0 and plus 0. Then we have 2 into 1 is 2, minus 1 into 0 is 0, which is equal to transpose. And okay, 6 minus 0 is 6, 0 minus 0 is 0, 0 minus 2 is minus 2, 6 plus 3 is 9, minus 9, and then 12 plus 6 is 18, 2 minus 2 is 0, 0 plus 3 is 3, 0, and 2 minus 0 is 2. Now we are going to find its transpose. Finding transpose means that we have to convert the rows into columns. So 6, 0 and minus 2 is the first row, so it will become the first column, 6, 0, minus 2. Then we have minus 9, 18 and 0. So minus 9, 18 and 0, then is 3, 0, 2. Now we have this adjoint of A over here and the determinant of A over here, which was 18. So now we are easily going to find A inverse. Why are we going to find A inverse? Because the question was to find A inverse, and hence we have to prove this equation as well. So we are going to find A inverse right now, which is equal to adjoint of A divided by determinant of A. So we are going to write this adjoint of A over here, which is then divided by 18. So 1 by 18 multiplied with this matrix. So what do we get when we divide 18 by this entire matrix? Each one of the entry is going to be divided by 18. So 6 by 18 we get 1 by 3. Then minus 9 by 18 we get minus 1 by 2. 3 by 18 we get 1 by 6. 0 by 18 gives us 0, 18 by 18 gives us 1, and then again 0 by 18 gives us 0. This row was quite easy, yes? Minus 2 by 18 gives us minus 1 by 9, 0 by 18 gives us 0, and 2 by 18 gives us 1 by 9. So this is our inverse matrix, multiplicative inverse of A matrix. Now we are going to prove this equation, which is this one written over here, A into A inverse equals A inverse into A, which is equal to identity matrix. So first of all, we are going to find this one and we are going to prove it that it is equal to identity matrix. Then we are going to find this one and again we are going to prove it equal to an identity matrix, and therefore all three will be equal. So first of all, we are going to write that what is exactly an identity matrix. Do you have an idea? Okay, identity matrix is, for a 3 by 3 order identity matrix, we have 1, 0, 0, 0, 1, 0, and 0, 0, 1. The diagonal entries are 1 and all the non-diagonal entries are 0. So we are going to find A into A inverse, and we have to prove that it is equal to this identity matrix. So what is A into A inverse? We are going to write both these matrices over here to multiply them. We have practiced matrix multiplication so many times that now you should stop this video over here and then multiply these matrices together and then resume it and see that if you have done it correctly or not. Otherwise, if you haven't learned it yet, so then you must learn it right now, and then for the next time you are going to do it this way so that you can know that whether you have learned it or not. So we have this first row 2, 1 and minus 3 multiplied with the first column over here. So we are going to write it as 2 into 1 by 3 plus 1 into 0, which gives us 0, so we are not going to write it. And then the last term is minus 3, which will be multiplied with minus 1 by 9. So we these two negative signs when multiplied together will be cancelled. So we have 3 into 1 by 9. Then for the second row and the first column, we are going to multiply the second row with the first column. So 0 into this gives us 0, 1 into 0 gives us 0, and 0 into this one gives us 0 as well. So we are going to write 0 as the result. Then we have this last row and first column. So this last row will be multiplied with the first column. So we have 2 into 1 by 3 plus 1 into 0 gives us 0, and then plus 6 into minus 1 by 9. So we have plus 6 into minus 1 by 9. For this entry, this is the first row and the second column. So we are going to multiply this first row with the second column. So we have 2 into minus 1 by 2, 2 into minus 1 by 2. Then we have 1 into 1, so plus 1 into 1, which gives us 1, so we are not going to write it, okay. Then we have minus 3 into 0, so we have 0. Now we are going to, for this entry, we are going to multiply the second row with the second column. So this is the second row and this is the second column. 0 into this entry is 0, 1 into 1 gives us 1, and then 0 into this entry is again 0. Then we have this entry. For this entry, this is the third row and the second column. So this is the third row and this is the second column. So we are going to multiply this row with this column. So 2 into minus 1 by 2. Then we have plus 1 into 1, which gives us 1. And then we have 6 into 0, which is obviously equals to 0. For this entry, we are going to multiply the first row with the last column. So this is the first row and this is the last column. So we are going to multiply them. 2 into 1 by 6. 2 into 1 by 6. Then we have 1 into 0, which obviously gives us 0. And then this is minus 3 into 1 by 9. So we have minus 3 into 1 by 9. For this entry, we are going to multiply the second row with the last column. So second row and the last column, we have 0 into this entry gives us 0, 1 into this entry gives us 1 into 0 gives us 0, and then 0 into 1 by 9 gives us again 0. So this as a whole is going to be 0. And this for this entry, we are going to multiply the third row with the third column. So this is the third row, this is the third column. So 2 into 1 by 6. We are going to write it over here, 2 into 1 by 6, plus 1 into 0 obviously gives us 0, so we are not going to write it over there, and then 6 into 1 by 9, plus 6 into 1 by 9. So this is the next step. We are going to multiply all of them and then solve them. So 2 into 1 by 3 gives us 2 by 3, plus 3 into 1 by 9 gives us 1 by 3. Then we have 2 into minus 1 by 2 gives us minus 1 and then plus 1. Then we have 2 into 1 by 6 gives us 1 by 3, and then minus 3 into minus 1 by 9 gives us, sorry, this is not minus 1 by 9, it is plus 1 by 9. So minus 3 into 1 by 9 gives us 1 by 3. Sorry, minus 1 by 3. Minus 1 by 3. This entry is already 0, 1 and 0. This row is the nicest row ever. Now we have 2 into 1 by 3 gives us 2 by 3, and then plus 6 into minus 1 by 9. 6 is 3 2s are 6 and 3 3s are 9. So we have minus 2 by 3 over here. Minus 2 by 3. Then we have 2 into minus 1 by 2 gives us minus 1 plus 1. And then we have 2 into 1 by 6, 2 3s are 6, so we have 1 by 3, plus 6 by 9, 3 2s are 6 and 3 3s are 9, so we have plus 2 by 3. Now first of all, we are going to cancel the negative and the positive ones. So minus 1 plus 1, 1 by 3 minus 1 by 3, 2 by 3 minus 2 by 3, and minus 1 plus 1. So we have to solve this one and this one. What is 2 by 3 plus 1 by 3 equals to? The LCM is 3, and the numerators are going to add, which is 2 plus 1, which gives us 3 by 3, which is equals to 1. So wherever this is written, we are going to write 1, and again this is again the same one, so we are going to write 1 over here as well. So we have 2 by 3 plus 1 by 3 equals 1, then 0, 0, 0, 1, 0, 0, 0, and this one is again this, so we are going to write 1 over here, and this is an identity matrix. So we have proved one side, and now we have to prove that A into A inverse is also equals to identity matrix, and then we are done with this question. I know it's very lengthy. Okay, we are going to name it 1 so that we can refer to it again. Now we are going to find A inverse into A is equals to. First of all, we are going to copy these matrices but in opposite order. So this time we are going to be real fast. So for the first entry, we have the first row and the first column. So 1 by 3 into 2, 2 into 1 by 3. Then we have this term as 0 and then 1 by 6 into 2. So plus 2 into 1 by 6. Then for this entry, we have the second row and the first column. Second row, first column, 0 into 2, 0, 1 into 0, 0, and 0 into 2, 0. So we have 0 over here. Then for this entry, we have the third row and the first column. Third row multiplied with the first column, minus 1 by 9 into 2. So we have 2 into minus 1 by 9. Then we have 0 into 0 gives us 0, and then 1 by 9 into 2 is plus 2 into 1 by 9. Then we have this entry, which is first row and second column. So first row multiplied with the second column, we have 1 by 3 into 1, we have 1 by 3. Then minus 1 by 2 into 1, we have minus 1 by 2. And then we have 1 by 6 into 1 is plus 1 by 6. Then we have this entry, which is second row and second column. So second row multiplied with the second column, 0 into 1 gives us 0, 1 into 1 gives us 1, and again 0 into 1 gives us 0. For this entry, we have the second row and third row and the second column. Third row multiplied with the second column, we have minus 1 by 9 into 1, minus 1 by 9. 0 into 1 gives us 0, and 1 by 9 into 1 gives us plus 1 by 9. For this entry, we have the first row and the third column. First row multiplied with the third column. So 1 by 3 into minus 3, we have minus 3 into 1 by 3. Then we have minus 1 by 2 into 0 gives us 0, and 6 into 1 by 6, plus 6 into 1 by 6. Then we have this entry is second row and third column. Second row multiplied with the third column, we have minus 3 into 0, 0, 1 into 0, 0, and 0 into 6, again 0, so this is 0. Then we have the last row and the last column. Last row multiplied with the last column, minus 1 by 9 into minus 3, so we have minus 3 into minus 1 by 9. Then we have 0 into 0 gives us 0, and 1 by 9 into 6 gives us plus 6 into 1 by 9. Now we are going to solve it. 2 into 1 by 3 gives us 2 by 3, plus 2 into 1 by 6 gives us 1 by 3. 2 1s are 2 and 2 3s are 6. This entry is 0. 2 into minus 1 by 9 gives us minus 2 by 9, and then plus 2 by 9. Then we have 1 by 3 minus 1 by 2 plus 1 by 6. We are going to write it. No, we are not going to write it as it is. We have to solve it. The LCM is 6. 3 2s are 6, so 1 2s are 2. Minus 1, okay, 2 3s are 6, so minus 1 into 3 is minus 3. Then we have plus 1 as it is. So 2 minus 3 is minus 1, plus 1 gives us 0 by 6, which is equals to 0. So here we are going to write 0. Then we have minus 3 into 1 by 3. These are cancelled. 6 into 6 cancelled. So we have 0 over here. Then 1 and 0 as it is. Minus 1 by 9 plus 1 by 9 are cancelled. 0. Minus, okay, 3. 3s are 9. And 3 2s are 6. 3 3s are 9. So we are going to write over here 1 by 3 plus 2 by 3. 2 by 3 plus 1 by 3 and 2 by 3 plus 1 by 3. We have 3 as LCM, 2 plus 1, which is equals to 3 by 3, which is equals to 1. So this is also 1, this is 1, these two are cancelled. So again we are going to get identity matrix, which is equals to 1 0 0 0 1 0 0 0 1, which is equal to identity matrix, and this is 2. Okay, what we have proved to this true we have proved that A inverse into A is equal to identity matrix. Okay, where is 1? From 1 we have proved that A into A inverse is also equal to identity matrix. We are going to write it over here. A into A inverse is also equal to identity matrix. So both of them are equal to identity matrix. So we are going to write it as A inverse A is equals to A inverse, which is equal to identity matrix. And this is what we have to prove. Thank you.